Okay, good afternoon. I hope everyone had a good lunch and got a nice healthy dose of the sunshine. It was great. And thank you for coming back in. I think you won't regret it. We are starting out this afternoon's session with a presentation from Brian Sweeney. Brian Sweeney is Senior Project Manager and Supervisor of the Construction Management Staff at Housing Development Center. Brian managed the construction of the second largest Ecoroof in Portland at Gray's Landing, which is an affordable housing project in South Waterfront developed by REACH CDC. His presentation will focus on technical challenges, creative solutions, and lessons learned from this ambitious endeavor. His presentation is entitled Adding an Ecoroof to a Project Under Construction at Gray's Landing. Feel welcome, Brian.
Good afternoon, everyone. Some of my thunder has been stolen. She's described what I was going to describe. So before we get started, I'd like to have a sense of the audience that I'm speaking to. How many people here are landscape designers or landscape architects? How about contractors, material suppliers, installers, people that make it work? Architects? Wow. Government? I think that's just other. Okay. I'm sorry, I kind of ran out of categories there. At any rate, we were hired by REACH Community Development. REACH Community Development is a large nonprofit housing provider in the kind of the metropolitan area of Portland and other locations in the state as well as in southwest Washington. And they responded to an RFP from Portland Housing Bureau to develop a project in the South Waterfront. The South Waterfront area has received, I don't know, I did something here. South Waterfront area has received a lot of public financing, and part of the deal was that there was supposed to be about 700 units of affordable housing provided. And until this project was done, there was none. So there was a lot of impetus on the part of the city to award a contract to a developer, and REACH was the successful recipient, and they hired us to be their development consultants and their owner's rep. The project, for those of you who don't know, right here, this is the old spaghetti factory, OHSU. The tram is right here, and some of the towers and other ones that have not gone in yet. The site was a brownfield. It had been, if it had structures on it, it was a long time ago. And it was partially remediated before we took possession of the site, and we had to finish the rest of that work. So we had that hanging over our heads in terms of our construction contingency, not knowing what the extent of that was. When we got the project, it had already been permitted. It had been designed by a private developer. The city had purchased it from them with permits, and we were kind of stuck with some of the considerations and some of the design issues that went along with that. So part of the reason we were hired was to ensure that this project received LEED Silver certification, and in fact, we wound up receiving certified as Platinum project. But one of the things I was challenged with was to add more green building sustainable features, and hence the Ecoroof, which brings us to today. Our initial stormwater system, this is just like a brief summary of what's going on here. I kind of interrupted myself. 6 stories, 5 wood frame over 1 story of concrete, and then there is at street level, and then there is an underground parking of 1 story. 209 units. Total project costs, soft costs included $50 million, $35 million in construction, and an Ecoroof cost of $360,000, for which we received compensation back from BES of $145,000, $5 a square foot. The initial stormwater management system was based on a courtyard. This is the 6-story building, and this is the second floor courtyard. In that previous design, the courtyard was almost all planters because the roof was cleaning the roof water as well. And so what we did was we redesigned the courtyard to make it much more useful for the residents, and by reducing the amount of planters primarily. And then we went to a green roof system to take care of 70% of the site that's covered by the roof. These arrows here show the basic kind of scheme of stormwater off the roof into these drains. They go into a pipe that runs under the courtyard and into a water tower feature right here. And then the courtyard itself is cleaned by 8 inches of sand that also goes into a water feature right here. Downspouts here, there's downspouts internal that go out to here. There are some planting beds here as well. And then this water tower contains storm runoff, and there are these 3 decorative stainless steel runnels right here that the water trickles out of when this starts to fill up and fills this container up. And this, as you can see, there's a few lonely vines. This picture was taken a few months ago. This eventually will be covered. And then, of course, the overflow from that goes out into the street stormwater system. Because the building was already permitted when we got it, it means it was also already structurally designed. And it was designed with a roof load of 15 pounds per square feet. And we, adding the green roof, doubled that to 30. And so we had to completely redesign the entire wind and earthquake lateral resistant system. And fortunately, the timing was such that when we were doing the garage level, we were able to speed up that structural design and get it permitted. We had to go through another design review, a type 2 design review, in order to do this work. And we then were able to beef up the structural system in the process as we were coming out of the ground. We probably didn't have a month to spare. This is more just diagrammatically to show the landscape architects, OTEC, were working on the design, and they chose a rectilinear planting method. There's 4 main groups. There's 2 groups of sedums and a group of other succulents, and there are blue sedges, blue fescue, excuse me. I can give you some numbers there with that. There are 57, almost 58,000 plants. Everything was planted from pots, of which there's 26, 14, and 4 thousands of the succulents, and then 12,000 blue fescue. It's a fairly complicated roof structure. So on top of the plywood deck, there's a vapor retarder. There's insulation, R30, rigid. There's an aluminum mesh, which is part of our leak detection system. Coverboard, it's an SBS torch down roof, leak detection wire, root barrier, filter fabric, and drain board, and then soil with plants. So it's easy to see how we picked up that extra 15 pounds per square foot. The aluminum conductor is a pretty interesting thing. It's a tight mesh that lays down under the protection board, and then above the roofing membrane, there are 6 large loops of wire that break the roof up into 6 zones. And if water gets through the roofing membrane, it causes electrical connection to be made between the leak detection wire and the aluminum conductor. And so someone with training and the right equipment can go around and pinpoint a leak to within a square foot, which is pretty good on a 30,000 square foot building. So this is what the roof looked like when we were ready to start the Ecoroof project and the process. So this is our SBS, our modified bitumen torch down roof, before the wire loops had been put on. Here is leak detection wire that go off into different zones, something quite as simple as that. This is just one of the drains and overflows in the center of the roof. Here they're rolling out the root barrier and then the combination of the drain and filter fabric and the first soil. Now, we were lucky to have it this time so that we still had our tower crane on the project. We had hundreds and hundreds of bags, large bags of soil and rock and roofing materials that we're able to use that tower crane with, which otherwise would have been quite a problem to get that equipment, to get all this up here. We're about 75 feet in the air, which is why everyone's tied off. The plants were all brought up by hand, pallet at a time, all 60,000 of them. Came up in the elevator, and then they had to be carted up the stairs to the roof. And here they're being laid out to start the array. There's solar panels on the roof for a hot water system. This is where the weeds are growing the best right now. Here's the roof planted before the netting. So there's crushed gravel pathways at the perimeter and connecting, and these are already starting to get sedums growing in them. So we were allowed to count those as part of our pervious surface. And then here's the roof in October of last year, planted, the jute netting right over the top of all the sedums with the fescue allowed to get cut and brought through. And that's about the same position from last week when I was up there. So in 7 months, we've gotten to here, 7 months during winter. And we have, there's been no maintenance done yet to this. They're in the process of trying to find maintenance crews now. Our irrigation system is a spray system. We opted out of a drip system. Doesn't seem to work very well with soil this light. The water just goes right through instead of spreading out. So we can control it really well. We expect to use this for 2 years, depending on global warming. And then it will be shut off but not abandoned. This as well as the courtyard system are all on electronic, kind of a high-tech electronic that measures the moisture in the soil before it turns on. Very water efficient. So this is how cost worked out. Down here, these numbers here, $105,000 to upgrade the structural frame of the building, and $41,000 to do the design and the engineering. We're not including this in the numbers. This would not be there if you were doing a new project. It would just be part of the design of that project. This was done over and above the original design work that was done and engineering work that was done. So you can see here these kind of pre-soiled numbers, plants, irrigation, and then miscellaneous materials, all the edging and so forth that go into it. So we wind up with a total cost of $13 a square foot. And that's, as I said, does not include the engineering. Just about what we thought we were going to get to. This job was funded by the state, and so boldly prevailing wages take effect, and that adds about 15% to the, you think that's right? About 15% to the hourly rate. And so you can kind of interpolate that for a project that you might be working on. I think most people here understand the reasons for doing this. All of these really apply to this particular project. And we definitely are seen by neighbors. There's buildings that are 40 stories high near us. They're looking right down on it. Some of the decisions that were made and things to consider when you're doing this, I talked about the irrigation. When you're on buildings this high, you have to be able to ensure that you've got water pressure up at that height. The jute netting is required for high winds. Also, it helped dealing with the birds as well. Coordination with a construction crane, that doesn't necessarily always happen. Construction cranes are very expensive to rent by the month, but it's something to keep in mind when you're doing that kind of constructability analysis with the contractor. And then the initial weeding, which needs to take place now. And I've already kind of browbeat them about it, but there are some fairly enormous weeds up there. The roof is not accessible by the public. It's not accessible by the tenants. The parapet, as you saw around the edges, is only 2 feet high. And so the only people that get up here are maintenance. But nevertheless, we don't want weeds to take over and then die during the winter. As I showed you, the post-permitting design added a lot to the cost. Going through design review again took about a couple of months. Potted plants come with insects, and so we were up there replanting things that were being pulled out by gulls and crows. It's important to understand the weight issues, and both the landscape architect and the engineer, structural engineer, really emphasized that when I spoke to him afterwards. There are no ASTM procedures for soil blends, and so you have to be very careful about how you're sourcing soil to make sure that its saturated weight is going to be what you're designing for. You saw what the difference was between 15 pounds a square foot and 30 pounds a square foot. The difference was $100,000 in engineering and strengthening the building. And so I think that lends itself to understanding the forces that are at work, especially when you're 70 feet in the air with this high lid that's shaking back and forth. And that is, that's my presentation. I want to point out that the people that helped with this, it was an intense collaborative effort because of the compressed timeline. Walsh did a great job. M&M, our contractor, our landscape contractor, did an excellent job of understanding schedule. And OTAC and Kramer Galen were great. Michael Bond and Ingram Moyson was the architect on the Pearl Family Housing roof, which is the largest roof in the city. And the contractor was the same on that too, Walsh. And so Michael's got 60,000 square feet of green roof under his belt in 3 years. It's pretty amazing.
So we have time for questions.
Do you have any savings on stormwater facilities with the roof, or do you just trade?
We traded. You know, we basically went by the BES stormwater manual. It was designed for the 10-year event. We just simply shifted the emphasis from the courtyard to the roof. So we went to 70% on the roof. I think we may have picked up some efficiency, though, because we have such a larger catchment area at which to hold the water. So the civil engineer, Matt Klein over at OTEC, told me yesterday that he ran some quick numbers, and this system would convey a 100-year event, not just a 10-year event.
Is the leak detection system in the cost, or was that already going to be in the cost? Was it a ballasted roof to start?
No.
So I didn't see that in the cost breakdown. And what?
I thought it was in there. If not, it would have been under the miscellaneous category then, because I got the numbers from Walsh, and they did take all that into account. We only did the leak detection because of the green roof.
Yeah.
As you would know, it's just a little more difficult to find a hole.
Is that monitored constantly?
No, it's not monitored at all. I think you can get systems that are, but they're really spendy. No, I take that back. There is a monitoring. There's a monitoring that tells you that there is a leak, and it'll tell you to the zone. So I said there's 6 zones up there. So those are what, about 5,000 square feet a zone. And then somebody comes out with like a divining rod, and they walk around, and it, you know, it registers, and they pinpoint it down. And I think a lot of it has to do with how well that device is calibrated and how good that person is at understanding what they're doing. So I think you see something back here.
Yeah, I was just curious about the moisture detection. Is that part of the leak detection system? How accurate is it? Who manufactures that?
There is, I mean, the leak detection system works such that there has to be enough water or enough liquid to convey an electrical charge between those two, between the wires and the mesh. And other than that, there's no moisture reading that's going on. I mean, I guess that would be nice, but I think we're talking probably a fairly expensive system. I don't know. You could, there's my email address, or you get a card afterwards and I can let you know.
You use this leak detection system for flood tests, so to speak, or did you do a flood test to ensure that you didn't have leaks?
I think we did a flood test, didn't we? I keep looking back here to Bennett, who was one of the supervisors from Walsh on the project, one of the superintendents.
Yeah, we tested the leak detection system to make sure there was no leaks before we put the overburden on. And then after the overburden was on, we tested it again to make sure that it wasn't functioning.
You didn't flood.
No, we did not do a water flood test.
We didn't need to. It was put on in the rain. I mean, we had plenty of flooding on that roof. Right. No, basically, we covered the drains. We needed to do that because of connections, and so it was de facto flood testing itself.
What led to your decision for overhead spray irrigation rather than dripping micrometer or both more water? What led to your decision to use spray heads rather than drip or micrometers?
What the landscape architect explained to me was that if a drip system would not, because of the lightness, the porosity of the soil, does not spread the water out, and so you would need an incredible number of loops in order to cover all of the area. Whereas with the spray, they were able to pinpoint exactly where they wanted to put the water. So that was the explanation to me. It has a certain logic to it. I have a green roof on my house. It has a very similar soil depth to it, the same type of soil. And we had a drip system up there, and it just, you could see how it would bleed out for a foot or so on either side, and then there would be large dry areas in between. I just wound up watering it by hand until it was established. Any other questions?
It's not a question, just a follow-up to that. Is that you see the big weather plants, the roots like to go in the hole and the water comes out. Eventually, part of the holes in that drip system. Has he had any experience?
Yeah, I mean, there were so many other things going on at the same time that, yeah, it was. I mean, it was probably one of the easier things that we did on the project. It was just a very expensive thing to do. But between that and putting in the solar hot water, it was an incredible amount of money and an incredible amount of time and energy. But, I mean, yeah, I mean, in retrospect, I'm glad we did it. It turned out really well. It's become a model now. I mean, there are being tours of it for other public agencies trying to, spread the message.
There's one, you mentioned 15 pounds, we designed it for 30. So the building was originally designed for over 15 pounds per week, or what is that?
No. It was originally designed, the live load was, or the dead load not including the structure, so what we would call as a live load, was ballast. It was rock ballast. There was not going to be a green roof. That's correct. 30 is what it calcs out to based on the soil saturation density of the type of soil we were using.
If you had decided to go with 15-pound Ecoroof instead of 15-pound ballast, you wouldn't have had to do the extra structure.
Right, but I don't know that there is such a thing as a 15-pound. It would have to be a fairly thin, because if you're going to hold the water, if you're holding 4 inches of water on the roof, it's going to have so much weight to it. I mean, it's just, so you're talking about an eco roof that would be very shallow, like a couple of inches or an inch and a half. I'm not so sure how viable that would be. I don't know enough about the science there, so if somebody else, would chime in, that would be great.
They can do that.
Was there an analysis made of the future cost savings
No.
for the solar?
No, that would be great to do. It just was not.
For the solar system alone?
Oh, for the solar system.
The cost savings, is that analysis?
Oh, yeah. Yeah, there's methods for doing that. There's actually programs that do that for you, tell you what the payback is on a system. The payback on the hot water system on this building is 7 years, and that's based on a 41% utilization during the year. And a similar system on another project designed and installed by the same plumbers, getting over 50%. So it could be 5 years that that's paid back. But in terms of the eco roof, in terms of longevity of the roofing and the stormwater system, that sounds fairly complex to me to try to calculate what that would be. A lot of factors, a lot of variables.
Long term.
Yeah. Anything else? Thank you.
Okay. Our second case study this afternoon is from Thom Ross. He's down there. Thom is a woodworker and owner of a 1940 shop in southeast Portland that was retrofitted with an eco roof and his residence in 2012. Thom's going to talk about his project as a case study and kind of explain his motivation for why he went forward with this project. Title of his presentation is Paradise for $5 a square foot, and I have personally seen his roof, and I would agree, it is paradise. I can't talk about the cost, but it's a great looking roof.
Actually, there's a little hyperbole there. It's not really paradise exactly. It's up on a roof in southeast Portland, but it didn't cost quite $5 a square foot either, so that's okay. It makes up for it. So I had perhaps different goals than the goals that the overall public and the city have in mind for the roof. It was kind of selfish. It turned out it was going to be my front yard, and I was mostly interested in aesthetics. Oh, sure. I can't tell whether it works from. I can hear myself. I'm not accustomed to speaking in public, so nor have I ever done a PowerPoint presentation before. So you'll have to bear with me a little bit, I think. Anyway, yeah, I'm just. I go all day without seeing anybody sometimes, so this is very odd. In any case, it's the $5 a square foot thing was a big consideration for us. We wanted to keep it reasonably priced, and it was also the magic number, of course, that the BES grant allowed. So it's been we've adhered to it, and I think we've done a reasonably good job, but we don't have very many layers. It's very low tech. That was sort of the goal all along. So, just by way of orientation, this is the arrow points it out. There's a low building there in the background, built in the 1940s. It's continuous poured concrete walls. The building was overbuilt in terms of today's standards. It holds up more than, for instance, 15 pounds per square foot. They don't build them like that anymore, as they say, but as it turned out, it was great for us wanting to put a green roof on it because it was able to handle the gravity load without a lot of additional work. Well, 2x14 joists, 20 inches on center. Why 20 inches on center? I don't know. But apparently, there were fewer standards in those days. So when we bought the building, this was in 2000, and this photograph is actually taken from an apartment across the street that it was shortly after the apartments were completed in 2009, I believe. So we still had this leaky roof that we'd been maintaining for 8 or 9 years, and we finally had enough money to replace the roof. So that was part of the impetus for looking into this project of the green roof. Here's a little closer up picture of the roofing itself. Was built up a couple inches thick of mop down roofing, which weighed quite a bit. And so when we started to tear it off, the building was sighing relief. It was, but it gives you a little closer idea, a closer visual picture of what the existing conditions were there. But in any case, this is another part of the decision-making process here. At some point, about 5 years ago, I decided I wanted to build a house inside the shop building. And so this is some early foam core models and an early SketchUp rendering of that project. And as you can see, the house sticks up through the roof of the existing building. And we took a chunk of the roof off and took a piece of the building out and built a house from scratch from the ground up. And the roof becomes the front yard, so it becomes very important for the livability of the house, for our, as occupants, our well-being. As mentioned earlier in the healthcare presentation, we didn't really want to look out on a blank white roof. So that's another consideration. This is just a quick illustration of what we had to do to do the seismic upgrade. We didn't need a gravity load upgrade, but we needed to do the jiggle thing. So it essentially we had to tear off selected areas of the existing sheathing after having torn off the hot tar roofing, tearing off some of the sheathing in order to get at the structure, and then tying all or many of the joists into the concrete perimeter. Here's a shot of the new decking in place, which went over the straps in some areas and under the straps in others. And you can see the anchors along the side. This is all we've got underneath the TPO, the roofing material, and the water retention mat, and then the soil. So this is pretty much just a minimal that you can get away with, I think. Anyway, the structural upgrade was the plywood was nailed down in a specified nailing pattern with lots of nails in some spots and fewer in others. It's just an engineering specifications for the seismic loads. Here is I think this might have been the design proposal that we gave to the BES for the grant. It's pretty. It's pretty low key, it's pretty low tech, but it's accurate. The main point here that we wanted to get across was that we've got drainage. The low point is where the drains are going to at the top of the picture there, which is going to consist of river rock. And then everything else is based on where the posts in the building are. So we were able to have a higher load on the areas where the posts and the beams were in this existing building. So, that was determined. But we designed around that in order to give some 3D contour to the roof. Rather than having just a field of sedum, we were actually able to stack up the soil over a foot deep in some areas on top of the posts. So we've got some rolling hills on the roof that it really helps to make it more interesting. The drawing got blown up on top of the matting material, the water retention mat. So we knew where to put all basically it was just a full-scale map, where to put the rocks, where to put the tree wells. The T there is a tree just on top of a post. Low-tech irrigation system as well. It's just scheduled, actually, here's a good point. This was not Schedule 40 pipe. I have to talk to my contractor about this. Every time somebody steps on it, it breaks. It's that really thin wall irrigation pipe, and I've done a lot of repair work on it. So I recommend, if you're putting in an irrigation system, to use actual real Schedule 40 pipe, because it's going to get walked on, much more than a pipe that would be buried in the ground. So anyway, but it's just plastic pipe with just sprinkler heads. Same thing Brian was talking about is, if you've got drip irrigation, it just drips in that little area. So we do have the sprinkler heads on this. The intention here was just to use this for a couple of years, and we have used it just pretty much during July and August for a couple of years. It's on a timer, so it comes on and sprinkles in the middle of the night so that there's less wind to blow things around. And then in the tree boxes, we intend on irrigating in perpetuity probably, just because the trees are going to require more water. So here we are beginning to put down the rivers of the river rock. This is taken from the other side of the roof. You can see the simple irrigation valves in the foreground there. It's just regular household solenoid valves. And here we are with, crane. Crane, even though this is a little building, the roof is about 16 feet off the ground. It was still really necessary to have a crane, as Brian was talking about. In our case, we didn't have to have a tower crane or construction crane on site. We just got one of the cranes that's on the back of a truck, and we were able to get it close enough to the building that he could boom out over, and these totes that have holes in the bottom could be swung, and if you get it swinging on the right pendulum, you can actually kind of make the river rocks go the right way and make the soil go in the proper arc. So it's sort of an art to that. We used 3 different soil mixes as well, and in addition to the rocks on this roof, there's the bulk of the roof is just 3, maybe 4 inches of what they call the extensive, I think, mix. Is that right? Yeah, the extensive mix is mostly pumice and some ground up paper and stuff like that. It's really not much organic matter in it, but it's able to support the sedum really well, and it holds a lot of water. Then on top of the beams, we used sort of an in-between mix, and right on top of the posts, we used a really rich soil, garden soil kind of mix for the tree boxes to go on. And there we go. There are some tree boxes. Those boxes were made out of some of the old joists from the part of the building that we demolished. So they're eventually going to rot away, but the tree roots will, by then, maybe just be capturing the soil. There's the landscape designer in the background. That's Jenny. She was here today somewhere. She's now working for one of the suppliers of green roof systems. She was a contractor's intern at the time, and she did most of the work. So here we are. This is right in the same period, but it's dried out a little bit. You can see all the soil starts to look the same. But we were raking things out and contouring, getting ready for the plants. This is all the plants for, well, almost all the plants for an 8,000 square foot roof. We were, again, trying to save money. We were getting plants in a small format and hoping that they would grow, which they did, you'll see. In addition to this, there was also some black-eyed Susan, rubideckia, that we planted later, and there was some bee balm that we planted later, and those both went in the mound areas, which are sort of the the semi-rich soil. But these are all, let's see, there we are. You can see how sparse it looks at the beginning there. A couple of little pine trees and a maple tree in that shot, and then this is actually before the sedum was broadcast. I think, yeah, you can barely see it, but the sedum has been broadcast here. It came in just little, like individual leaves, and tossing it about. This is in the fall, which I think is probably important on this project. Planting the sedum in the fall allowed it to overwinter. Here it is. This is actually from the new structure. After the new structure had been, we finally got it framed up that high. So you can sort of get a little bit of an aerial view there. Again, this is right after the sedum was spread. And here we can see what happens just over the course of a month in this following spring. The April shot is just a little sparse bit of sedum, and then, but these sedums had the winter to grab hold, and then they just went crazy as soon as the sun came out. And so you can see it's planted in sort of areas of different kinds of sedums, but just as much as possible, not a grid work, trying to keep it kind of a natural flow to it. And some more recent pictures, there's just an idea of the sparseness in 2011. That was the same time those last couple of pictures were taken. And then this other picture was just the other day. A couple of things besides the fact that the sedums have filled in and some of the rock crests and so forth are blooming. You can see there are a couple of other differences. In the June 2011 picture, all those dark plants up in the front are heather, IRRIGATION, that all died. And I'm not sure exactly why. They dried up, it looked like. So it may have been under irrigating. Everything else was happy, but those didn't make it. Although you can see on the other side of the skylight there in the April 2013 picture, the purplish mounds are just the end of the heather bloom, and it blooms in the winter, holding on over there. So some of it died, some of it didn't. As time goes by, it's been interesting to watch sort of which areas thrive and which don't, and it has a lot to do, I think, with how the water flow is. It's a very shallow roof pitch, and so there are actually some areas where water sits longer than others. So trying to learn something from that if we want to replant things, putting the appropriate plants for the conditions in. We've got a shot from Bing down here. The Google Maps shot is really old. It's before we started. So I found one on Bing, but this was during the construction process. I think that's the contractor's van down there in the parking lot. So it was sort of right while we were still working on things. But you can see this, the sedum is beginning to take hold there. So here we are with the miracle of the iPhone panoramic photo just about a week ago. Gives you an idea of the entire roof. I'm standing up on top of the house portion and just sort of holding the camera out as I go around like that. But just looking at how well all the sedum is filled in by itself over the course of 2 years, 2.5 years now, it's apparent that it's not absolutely necessary to plant fully developed plants if you've got some time. If you need the instant gratification, it's great to be able to put down flats of sedum and have it done. And also, the denser the sedum is, the less likely the weeds are to grow. I found the areas right around the new construction where we hadn't really planted because we knew it was going to get stomped on. That is the area where the seeds, the weed seeds, congregate and grow. Any place the sedum are, it just seems like the weeds don't get a grip. So it's been very low maintenance in those areas. As far as weeding goes, the first year we were worried because it was so sparsely planted that the weeds would take hold. And I went out in February with about 100 pounds of corn gluten meal, which I've been told, and apparently it's true. It retards seeds from what you call it, from germinating. Yeah. So that it worked quite well. It didn't have very many weeds at all the first year. We had actually more weeds this spring in the area right up around the construction than we did before, when the whole thing was pretty much sparsely planted. So anyway, that's what it's looking like today. It seems to have worked. It didn't cost very much money. We didn't really overthink it or over-design it, and I'm hoping that it really will double the lifespan of the roof itself too, because if it does, it will have way more than paid for itself. If the roof costs $60,000 and the green roof costs $40,000, so in round terms, if the green roof can double the length of the life of the TPO, then it's a great deal. But the main reason was because we wanted it to look nice. So, this is what I'm working on this spring. This is the little hole in between the house, which is, I'm looking down. That's the house. That's the skylights into the shop. We're working on a green wall on the left. That's vertical. At the top, that's about a 45-degree angle, and getting ready to plant that. So maybe we'll have some more things to learn here, and we can look at a finished green wall / green sloping roof installation on a low budget next year. So that's about it in terms of the what I have to show you. I'm happy to answer questions. Yeah.
You said the water retention mat
Mat.
is actually carpet pad?
Yeah, it's a you need to get carpet pad that's completely inorganic because you don't want it to deteriorate. But yeah, it's just like 3/8 inch polypropylene, or maybe what do they call it, 20 pound or something. I mean, they rate it by the weight per yard. I don't know. Dan, what is it? what do they call that stuff? Carpet, just carpet pad, yeah. I mean, it's pretty generic. It's, it's the stuff that's made out of recycled plastic. Not the foamy kind, but the stuff that looks like that. That's it.
So you put a layer of the membrane and then that.
Right, a layer of the TPO. I mean, it's a regular white thermoplastic polyolefin roof. The heat welded stuff that it was put down in accordance with manufacturer's specs and everything. But then just between that and the soil was that carpet padding, which was, yeah. I mean, there it is. It's that thick, and it seems to be sufficient. With this kind of with a white TPO roof, you don't need a root barrier because it's a slick, hard surface that nothing's going to go through. It's like its own root barrier. So, but this seems to retain enough water to provide for the plants. I mean, the plants actually go down. The roots go down into the carpet padding as well as into the soil. Yeah.
I was wondering
Oh.
how the permitting process was prepared. Any that at all, was it full?
Well, there were actually a couple of permits involved with this. The structural upgrade for the roof was a separate permit from the permit for the construction of the house. But they kind of got tied together because we took a big chunk of the roof out of the existing building to build the house through it. And that became the sticking point for the permit. If we had just been putting a roof on the existing building without messing with the structure, or without taking a big chunk out of the structure, which is what we did for the house, it would have been much easier. The permit process, it was essentially no problem. It was permitted because the structural engineering had all been done. It all penciled out, pulled up the roof load. All we were doing was getting a seismic upgrade and then putting a new roof on. So that was easy. And then, it might not be easy for everybody, but we were again lucky to have a building that was overbuilt by today's standards in order to hold up the load that we were putting on it. So, if you have an older building, it might just not need anything. Yeah.
I was going to ask about the soil stabilization for the 45-degree.
Oh, well, it's a whole different system. That actually is going to, oops, I went the wrong way. That's going to require actually very little soil. That's I'm going to treat it the same way as the wall, which is essentially, it's 2 layers of the water retention mat or the carpet padding. And with a stapler, stainless steel staples, you define little pockets that you cut a split and you staple around it and you put your plant in the pocket with very little soil. And then you see all the piping is all full of holes. It's essentially a hydroponic system. There's not much soil involved. So you don't really need to worry about that. I think there will probably be some sedum that will be spread kind of on top of it, but that doesn't require much soil either. It's really kind of a whole different idea and it's different goals and different systems and everything from the eco-roofs that I think everybody else is talking about today, but it's and it doesn't have the advantage of slowing stormwater really either, because it has to be irrigated all the time. But that is a little pond down at the bottom there, and everything drains into that pond. And even though right now I've got it plumbed in through city water, the eventual goal, when I've got it all up and running, is to be able to have a closed system pump from the pond, which has fish in it, therefore fertilizer, back up through the roof. And yeah, that'll be maybe next year's project. Yes?
I'm curious, you staple the fabric, what are you stapling it into there? How do you keep the water from damaging the wall?
Right, both the wall and the roof have, there's a surface that's furred out from, blocked out from the roof and from the wall on pressure treated lumber. And the surface is, I use 1/2-inch Sintra, or it's like, Sintra's a brand name, it's like Kleenex. It's I think it's called expanded polyethylene or polystyrene. I'm not real good with my plastics, but it's a real rigid board, plastic board that holds staples quite well, holds screws. It's basically, it's as strong as plywood, at least.
So you would have a little air pocket?
Doesn't have air pockets in it. It's pretty solid. It actually weighs more than, I got 1/2 inch, it weighs more than just a 1/2 inch plywood. And it's what's been recommended in a lot of different places that I've read. So anyway, then that's what you're stapling to, is that stuff. So there's actually an air pocket behind it for circulation, and also protects the, so you're not stabling anything through the roof membrane. Yes?
I'm wondering about, could you say again, what was the depth that you're using for the trees, and how are you managing root control? How big are those going to be?
Right.
What's the thought there?
The trees are, well, you saw the boxes that the trees are sitting in. Those are 2 by 14 joists, and they're not sitting all the way down. So I'm thinking it's probably 15, 16 or so inches of soil there. The trees were chosen specifically for this because they aren't going to get too terribly big. The pine trees are dwarfs, and the maple trees are all, they're hybrid Japanese maples that are supposed to get 15 or 20 feet tall. Maple roots kind of go more out like that, so I'm hoping that they'll find their way out from under the box. And maybe when the trees are 15 feet tall, that there'll be enough stability from the roots being spread out that we won't have to worry about wind load on them. But if the tree blows over, then we'll deal with that, I guess, when it happens. The little pine trees, I don't think are going to be much of a problem. They're just so little. Yes?
It's like you really mastered the KISS, kind of mentality there. Keep it simple, stupid. And I just really appreciate that. One, you make it seem very accessible to take on this kind of project where most of us come up with these really complex ideas. You kept it simplistic. One thing I wanted to ask you about was the planting aspect. I mean, it's brilliant how you talk about keeping it very sparse and letting it grow in. But what about weeding? I mean, was that a big concern for you, or did you look at all vegetation as a win?
Well, no, I really would prefer to have, not a lot of invasive weeds, and there are actually some weeds that they're pretty noxious too. And that's why, as I mentioned at the beginning, when it was sparsely planted, we went out of our way to put down the corn gluten meal to retard the possibility of weed seeds germinating. It seemed to work pretty well. Lately, I've been doing some hand weeding, but as I said, now that it's filled in, it just doesn't seem to be supporting too much weed growth. I probably spend maybe an hour every couple of weeks up there filling up 2 or 3 5-gallon buckets with weeds. It's not awful work, but if you don't keep on top of it, then I suppose it could become more of a problem. But it's I guess maybe that whole idea of the low-tech solution is, you just gotta, it's work. Just do it. So, rather than try to design a system or something, just deal with it. So. Yes?
how did you finance this project? Are there any issues with getting money to do this? And second question, if you had to do it over again, is there anything you would change besides doing it on the scale of 45 people?
Actually, that's probably about the only thing I would change. But the financing was, well, the roof, the actual green roof portion of the project, which the $5 a square foot portion, everything above the level of the TPO roofing, was actually paid for by the city, the BES grant that we received. So that was actually, and I think our contractor even waited to get paid until after we got or waited for a lot of his money until after we got the money from the city. So there wasn't really any necessity for financing there. The rest of it was just, it was a new roof. It's what you do when you're a building owner. You save up a bunch of money until you've got almost enough, and then you do the job. And if you need to put it on your credit card, you deal with that. We kind of looked at it as sort of a long-term maintenance problem in terms of the roof, and then an investment that fortunately the city was willing to make in the future. So it's preventative maintenance, really, of putting the green roof on.
Good.
That it?
Thank you very much. Matt's got a couple words for us, then we're going to take a break.
So, thank you guys, and thanks Thom very much. Thanks Brian. It's so good to see some case studies and some examples, and I think I've said this 100 times in the past week. It's hard to have a session of an event like this where you focus on case studies and you have 2 case studies. And I think that what Thom and Brian bring are 2 very different examples and approaches and different purposes for having green roofs on those buildings. And hopefully that shows you kind of 2 different ways of looking at the same type of idea, and from very different places having the same or similar outcome with a large number of benefits and packaged benefits to both the property owner and to the city. So that happened because I closed my laptop. I think that's the first time that's been dark all day. So I wanted to say a couple of words about just part of what's kind of specifically what has sponsored what's happening outside later this afternoon, and more generally about what's been happening, this ongoing dialogue that's been outside of a forum like this, and more in a forum like the Lucky Lab Brew Pub Side Room kind of thing every month for the last 4 years. But how many people have been at a GRIT meeting before? How many of you guys have been? That's great. I like seeing all the hands go up. So if you haven't heard of GRIT or know what that is, then this is going to be a very shameless plug for GRIT. And the reason that's not only acceptable but a good idea is that members of GRIT have volunteered a lot of time to develop the program for this event and this year and last year's event, and really a lot of what drives our work at the city is the dialogue that happens with members of GRIT. Again, that's the Green Roof Info think tank. I keep saying GRIT, but it's made up of everybody that works in the industry that wanted to join, whether professionally working in it or just an enthusiastic supporter, or somebody that just likes to see green roofs and trees and things like that. And we've had all different kinds of involvement from all different kinds of folks. And what's happened, while we've had plenty of people that have joined in and spent some time and then have moved on to other things, what's happened is that over the last 4 years we've had 400 people mostly from the local area, but as far away as Peru and the Middle East and from countries all over the world that are involved in this online dialogue. And every month some of us locals will meet and talk about the challenges in the green roof industry and what we can all collectively do to kind of address those challenges. Some examples have been that we've had some projects that have maybe lost some funding or lost some support that needed a little elbow grease. And so some of us have put on some jeans and gone out and pulled some weeds. We've had some great successes engaging with discussions about statewide policy like the REACH code and submitting comment on that. We've had a great deal of involvement with a number of the businesses in the local area and have represented the green roof industry when going to city council, when talking about major issues that affect the local industry. And I think what we've all seen in the last 4 years is it grew from 4 people sitting at a bar table at the Lucky Lab turning into 25 faces every month that kind of change and go in and out, is that I think what we've realized is that the dialogue is important to continue. And without that dialogue, it's easy for things to kind of wax and wane and fade away. So if you're not involved with the group, then I encourage you to get involved with the group. There's a table outside. There's a website, greenroofthinktank.groupsite.com. So I butchered that website. There's a website that's out on the table here, and you can get it there. Or you can email me and I can share it with you. The reason I'm bringing it up is that the group's actually going through an evolutionary stage of sorts, and we're seeking nonprofit status. And it will have a board, and we're actually going to get a little more formal. And that's because the sense is that the green roof industry needs a little more advocacy, both locally and regionally and even further out. So the more that things happen, the more we would love more involvement from those of you. And if you feel that that's something that you want to talk about further, come talk to me, or you can talk to Elizabeth Hart, you can talk to John Crumrine, Dan Manning, any number of us that'll be out there would love to talk to you more about it. So we have a 15-minute break. We're going to have 2 more presentations, and then we'll have the vendor showcase, and we're waiting on, if not anymore, a nice keg of Dead Guy Ale, which will be out there with some refreshments. So grab some coffee or tea, and then we'll come back in for another half hour, 45 minutes. Thanks.